Okay, now we've done shifting left and right, or translating left and right, and we've done translating or shifting up and down. We can see what those look like. So, and now we can combine those two in order to get a vertex anywhere in the real plane. So that's your basic function that we've been working with. F of x equals absolute value of x. And the question says to write the, well, I didn't write out all the instructions, but you're going to write the function that comes from this function, the f function, but shifts it, the graph of f, left 5 and down 4. Okay, so here's the original function with the vertex at the origin. That's f. I did it in green to match the f, green of f. Right? So I'm going to define a new function g of x. Now I used f of x and g of x. Sometimes these problems will have y and y. And I just use f of x and g of x because it's important to understand that those will not be the same y's. They're different y's. So calling one f of x and the other g of x helps us to not get the two different y's confused. So for g of x equals x plus 1, or x plus 5, what kind of shift is that? Well, you take x plus 5, you set it equal to 0, you get x equals minus 5, right? X equals minus 5, that's a shift to the left by 5, which means the origin, the vertex, which was first coordinate 0, you're subtracting 5 from that, and so you end up with first coordinate negative 5. And then I'm going to, so that shifted left 5, which is what I was asked to do, shift it left 5. And I want to shift it down 4, so on the end of it, I subtract 4. That shifts. And now what that's doing is, it's taking your y's and subtracting 4 from every y coordinate. Because my y, before I do the minus 4, my y is actually absolute value of x plus 5. So after I've done that left shift. So if my second action is to go down 4, then I have to subtract the 4 on the end from the old y to give the new y, right? And I'll show you this in a sequence, one step at a time with a square root function a little bit later. So the vertex now is negative 5, negative 4. You could have written that just from the instructions, right? Shift left 5 and down 4, and you're given a graph with the thing at the origin, and you just go left 5 and down 4. And the shape doesn't change when you do this. When you do these translations, the shape of the function remains the same, and its orientation remains the same. It doesn't get turned by 30 degrees or flipped over, or turned by 90 degrees or reflected across the x-axis, none of that stuff. We do that stuff later. I'll show you what does that. Okay, so I made two shifts. I showed them both together. I could have done one at a time. I could have had this go left 5, and so it would be here, right? And that would be absolute value of x plus 5. And then subtract 4, and it would bring it down here, right? You can do it the other way on this too, but that's the best order to do them in, is a better habit. Work out from the x. Doesn't matter here, but it will with some other things later, especially reflections.